Okay, so the next part, a little bit more technical, but I'm only giving an overview of this, so I won't be going into too much detail. So this part's about APQP, Advanced Product Quality Planning. It's kind of a new thing introduced into aerospace. It comes from the automotive sector, and included in it is PPAPs, which these are terms you may have heard of, but it's actually all come from the automotive sector. And what they've done is they've tweaked it to suit the environmental sector, but very, very similar. So if you've got experience of APQP or PPAPs from an automotive background, the same principles can really be adopted to apply it to an aerospace organisation. So I'm just purely going to give an overview here, because otherwise we'll be here for days and days really if I cover every element. But what we probably might do is do some smaller webinars just on the specific things which you can attend. But it's such a vast subject matter, we just couldn't physically cover it. But it'll give you a flavour, and then if there's an interest we can do something else afterwards, or if you've got specific questions or you want to look into it further, we can do something afterwards. You've got all our details. So, right. So one of the standards that I mentioned earlier that they're kind of looking at bringing into the ISO scheme is AS9145. Okay, so that's AS9145 is a APQP and PPAP standard. Okay, so the whole document brings in a lot of these elements that I'm going to give you an overview here. It's quite a detailed standard, and it's not one of those you can look at and just go and do. You've got to look at it and then go and think about other things that are impacted by it. So some of the bits that are mentioned in there are FAIRs or FMEAs, but there'll be a line, you must do a FMEA, you know, it's that type of thing. So then obviously it takes quite a lot of work to actually achieve it. It's quite a detailed thing. It's intended for larger organisations, but actually you can implement some of the requirements yourself if you're a small organisation, or even some of the elements that are in there, which I'll come to, are quite useful to take out. So even if you didn't want to go through full PPAP or APQP or 9145, there are some very good little bits in there that are good anyway for a management system that's going to help you drive that performance that we're talking about. And if you're not a design organisation, then some of the sections don't count and things like that. So it all depends on your organisation, who your customers are as well. It all depends whether you need to implement it or not as a full standard or full approval. Like I say, there's some good bits in there that you can apply to anything. It's not intended for off-the-shelf items, commercial off-the-shelf COTS items, specifically really for new product introduction and any changes to ongoing ones. So quite a lot of organisations will do new product introduction as one of their processes. But I think they put that in there as a word into their process map without actually fully understanding and appreciating what's involved in a new product introduction. So this standard kind of forces you down that route to fully implement good controls around new products being brought into the business, or if you're going off designing, developing new things like that. It's a very good process, in all honesty, but not many organisations are doing it. But what we're seeing is it's starting to be flowed down through contracts. So as we're looking at your contracts that you get from your customers, we're starting to notice in there AS9145 or these PPAPs are being mentioned and things like that. So we can see there's a lot more talk about it in the industry, and the IQG are very much trying to promote this. They're holding webinars on it. Similar to this, I guess they're doing some themselves, which is on the Oasis database. They're starting to push out lots of material as well themselves. So I can kind of see something like this being introduced into the next version of 9100. It'll just be a small little bit just to get people used to it. And then I can see it sort of building up a bit. especially through the design bit and through the production part as well. I mean, I don't know, but I get that feeling. So there's 5 phases in total, which we'll come to, of a APQP, which are set out in the AS9145. Not all of them are going to be applicable, as I say. So if you're not a design organisation, then you don't need to do certain elements of it. Okay. So APQP, some benefits they expect to get from it, which are highlighted here. The biggest thing is you're kind of front-end loading the development process of new products being introduced or ones being updated. It's really to put a lot of effort in front end to save you time back end, and overall it will reduce time, should reduce costs, improve your customer satisfaction, give more attention to your customers. Just a more robust process of bringing new products into the business, into your program, rolling them out, qualifying them, and getting them, all through nice and smoothly with less errors, which at the end of the day will please everyone. Less rejects, more satisfied customers. There's a lot of benefits that can be introduced from implementing APQP. So this is the product development APQP model. A lot of people are going to be used to doing fairs, which you'll see kind of at the end. So the 5 phases across the middle in the dark blues, you've got planning, product design and development, process design and development, and product and process validation, and then the ongoing production and post-delivery, things like that. So most organizations, because there's not huge amounts that actually do the design bit, will just focus on section 4. As an organization used to doing fairs, one thing that is kind of part of this is PPAPs, which you've probably not done PPAPs. You might have heard it being mentioned. You might have had some customers muting it. So PPAP is part of that section 4. So it depends on your organization as to which elements, them all possibly, need to be introduced by you as an organization. But say fairs are the common one that people have heard of. That forms a small part of it. And fairs are in the AS9100 standard, just a single bit. So that gives a short overview of the APQP model. In theory, you should adjust it and you should do it multiple times depending on where your product is. So if you're doing a prototype, things like that, when they go into trials, and then when they're actually in production. So it should adjust depending on where you are in your overall process of development. It's quite detailed. Once you get the documents in place, once you've done the first one, it's kind of easier just to revise it. So it's a live document, like any risk assessment should be a live document. It's not done once and parked. So you should continually update it, review it, and make sure it's still applicable. Here's just a typical company when you're introducing new products. You're kind of tinkering with the development in this blue, kind of the blue shade in here. And then as you're kind of picking up momentum with your products, when you start getting into the manufacture, you're still developing. So you're kind of doing them both at the same time. You're putting in little resource at the front end, and it just takes a lot more people, middle and back end, to get the product out the door. And often what happens is you get delays, there's increased expense for you internally, things you didn't plan for. You didn't think about all the possible situations that you're going to come across when you're developing a product. So it's about putting in the proper planning at the front end loading all of your resources really, and it just makes a smoother process overall. And here's the model that they expect after implementing the APQP. So as you see in the blue shaded, all the problems and development and everything, it's all up the front. You just thinking about things, you're risk assessing things, you're identifying everything you can think of that could go wrong. And then when you actually get to product release, which is your purple line, all the problems are gone. You're not going to get all of them, we know that, but the majority of them. Yeah. So it's a straight ramp up to full production, and then you're there. Okay, when you go back here, it takes a lot longer for you to get to full production because you're resolving issues. You're still fixing things. You know, you get a little demo out there, oh, that didn't work. So you have to go back to the drawing board. So it delays things. So the idea is do all your effort up front. It just makes a smoother transition for production, really, when you get into full production. So it should be on time, should be in budget, customers should be happy. You're not wasting money on resources unnecessarily, and all your problems are solved at the front. So there's three key pillars of an APQP. That's kind of the principles, I suppose, behind what it's there for. So there's organizational commitment and management support. It's kind of a given, really. There's a lot of management systems nowadays, and we know what 9001 is and AS. Expect a lot of management input, a lot more commitment from the management team. They can't just put it onto a quality manager and let them get on with it. So a lot of standards are going this way, really. They've got to be behind it, they've got to support it, they've got to give a lot of resources to it. So they've got to be behind it, understand it. Cross-functional team, can't be just left to one person to do this APQP. It needs a lot of different people to get involved in lots of different points throughout it. Yeah, you need quite a broad sectional team to cover this effectively. Argument's sake, a quality manager may not be able to do the design bit fully. You need people from the design team to get involved in it. So if you are going to roll out APQP fully across the entire organization, you've got to think about who needs the training, who needs to run with this, who needs to get involved in these project teams. A bit like Six Sigma or 5S, a lot of people involved in 5S, where you get different members of the organization getting involved, you get little project champions, things like that. It follows a similar principle. And effective project planning. Takes a lot of planning, this, a lot of milestone dates, getting things in diaries, things like that. AS9100 brought in a lot of that from project management. Expects a lot more project planning, and this just takes it to another level, really. Just tightens it up. And if you haven't got good project planning, in all honesty, you're almost wasting your time, because you're not going to save the time, because you're just spending it fixing other issues and not keeping on track, and it's just going to delay your entire process of bringing new products in, which isn't the idea. You want to get them in quick, smoothly, without any issues. So here are the 5 phases again. So phase 1, planning. Phase 2, product design and development. Phase 3 is process design and development. Obviously, there's a difference there. Product is the physical product, and then the process is anything that needs to be done to make that. Phase 4 is product and process validation, which is basically the manufacturing element of it, and checking that what you've made is correct. And then the ongoing production, use, post-delivery, so it's the after service things. The PPAP element, which some organisations would have heard of and possibly been asked to do, that comes in section 2, 3, and 4. Okay. So here are there's 11 elements that go towards the 5 phases. So we'll go into detail on some of these. So these are the elements in here that make up those 3 pillars and go into the 5 phases. So design record, design risk analysis, the DFMEA. The process flow, which quite a lot of you should be experienced with. Process FMEAs. Some organisations are doing these, I'd say, more often now. Trying to encourage some of the larger organisations that have got quite a lot of manufacturing going on to start doing FMEAs. They're not forced in the standard, but clause 8.1 is under the operational risk. It's kind of alluding to do these types of things. They're quite useful, not for everyone, because they take quite a lot of time and effort. But for larger ones that got a lot going on, they're quite useful. Control plan, that's another useful thing. Organisations should probably do this more often. These are some of the elements that I think you could take out, even if you're not going to do the full APQP process. Control plans, and I've got a little bit of control plan at the end to run through. MSA, okay, so that's your calibration, yeah, think repeatability, things like that. Initial process capability studies, so that's your initial trials. You know, running things through, making sure your equipment's up to scratch, CPK levels, things like that. Packaging, preservation and labelling, so that's the end part. And then your final fairs, which a lot of you are doing. And then customer PPAP requirements. So a PPAP is actually a full-on document, and a fair is part of it. So when you're putting new products out to your customers and shipping the first batch, quite often organisations are sending a fair with that. But a PPAP is kind of taking a little bit more information, and it's a whole pack that kind of goes with it. So it's a little bit more detailed, but you'll probably start seeing that a little bit more often. So you're probably doing some of these elements. Process flows, you're probably doing them anyway, because most organisations are doing process flow charts nowadays. You may be doing FMEAs. You're probably doing first articles at least, you know, fairs, things like that. So some of these elements you're already doing anyway. Okay, so phase one is the planning. So things to think about when you're planning in this phase. Some of the things you've got to do. So all these elements are broken down into here. And what you'll do is you'll see there's a lot of documents in here and things you need to do. You need to do a lot of this planning bit to be able to do the other bits. So you can't kind of jump a lot of it. You have to do it in order. So regulatory requirements, obviously you need to identify any regulatory requirements, kind of self-explanatory there. Any customer needs, so it's important to understand what your customers' expectations are. Oops, sorry. Yeah, when do they need things by, your key milestones, the volumes, the life expectancy. Probably don't need to know that necessarily if you're manufacturing, but especially if you're designing. Yeah, you need to be aware of what's the expectation, 20 years, 35 years, things like that, because you'll design that accordingly. So again, some of these elements you'll probably get anyway if you're doing design process effectively. You should be identifying them. Product and process assumptions, product performance, what's expected, and warranties, reliabilities, any quality requirements, technical requirements, any historical problems. So if you've got a similar product and you've had things in the past that have been failing out in the field, maybe you're redesigning something. So you need that data to be able to redesign those problems out. Changing materials. Obviously, as things like REACH came into play, that made people reevaluate some of their processes and practices, and all kinds of new legislation came in. Lessons learned, so best practices, just using information that you've got historically as a team. A lot of people will say, oh, we'll use lessons learned, but we rarely find anything that sort of tangible where we can see someone's documented some lessons and then those lessons are reviewed at the next time. People change, they leave organisations, so a lot of the time that knowledge is gone. So it's good to think about some of those lessons, documenting them, and you can then use them next time going forward. Again, it's just good business practice in a lot of cases for some of this. So I've got product design in there twice. Oh no, product and then process. And then company strategy, business plans, marketing strategies, industrial strategies, technical. Do the products fit with that? Because you could be looking at something and planning in it, but really is it around your strategy? Are you going down a route with this new product development that really doesn't fit your core targets, your core strategy? So it's getting you to think about things up front. Think of Dyson quite recently. He went off and looked at electric cars, spent I don't know how much, I know it was quite considerable, realised he couldn't do it. the market wasn't there, the end result was going to be too expensive. So I don't know what he spent on it, but really, maybe at the front end, he could have looked at that a little bit better, really, thinking about certain things. I mean, he's a better man than me, so I'm not going to judge the man. Okay, so the elements and deliverables. So really, it's the planning bits. This is what's expected to be shown and delivered as part of this. Okay, so project inputs, requirements, document, statement of work. That's really kind of a brief, what you're expecting to have in place. So I'm just moving my screen around a bit. Product design requirements, configuration control, product technical design, things like that. Project targets, any safety requirements. I do one company that does oxygen masks for that go into space, ejector seats, things like that. Ejector seats have to work at certain pressures, the masks have to do certain pressures, they've got bleed valves, everything. So those are quite safety critical things that they need to know as an organisation in order to design that product effectively, because otherwise they'll start using it in atmospheres that it's not designed to do. It's just things like that that you would think about if you're doing through the design. Key characteristics, critical items, important to identify them. I'll say that's a weakness in the sector. Us as auditors will go around and we'll ask, what are the key characteristics for these products or anything we're looking at? There's nothing on the drawings, and quite often the organisation doesn't really know what it's used for. It's quite a weak area in the sector itself. Designers should be communicating these key characteristics down to the supply chain, so they know what's critical, what things they need to control. When they do that, us as external assessors can then focus our attention on it. When we just see a drawing and there's no real key characteristics identified and the clients kind of say, no, they're not key, it's kind of hard for us to argue it. Unless there's specific things on there that say these are key, you know, we'll challenge some thinking, but it's kind of their word against ours, and they'll know the product better than us. So design organisations should focus on that a little bit more. Preliminary bill of materials, any subsystems, they'll get. It's early days in this. It's all planning. But you should be able to get some of these documents together, statement of works, rough idea of how the design flow is going to work, some sourcing, make-buy decisions, project plans, activities, dates, key milestones. Okay, so all these elements here, you should be able to do as part of your phase 1 of a APQP, and you'd expect to produce a lot of these documents. Okay, phase 2. Phase 2 is the product design and development. It's quite detailed. Design organisations should be putting a lot more effort into the design process, doing a lot more of the planning, identifying the key deliverables, failure mode and effect analysis, doing some stress analysis, things like that. So they'll need all the inputs from the planning process to be able to effectively do the design and development work. When you look at the AS standard for design inputs, some of those requirements that are already mentioned in the planning are things that I would challenge a design organisation on. I definitely expect life cycle, materials and things like that, because if you don't know that, you don't really know what to do in design. It will stop a lot of this back and forth with design. Oh no, don't like that material, don't like that. Stops a lot of questions. So do all the planning up front. Okay. So the elements and deliverables, design risk assessment analysis. So what you should do is look at the elements from the product that you're designing and think where the high risks are. I see quite a lot of just general risk assessments with the risk matrix being done. And these things are the ones that can critically impact the delivery, the service, the product itself. Highlighted as high risk, and then there's more attention put on those elements, so they'll manage it a lot closer. It's a bit like anything really when you do a risk assessment. Is your high risk stuff you focus on, the low risk you don't worry about, which you'll take care of. So the design organisation should be able to do things like this. People might have heard of the make with the design. So that's kind of a good process that people can work through that will cover a lot of these areas. Design records, so you should be getting good design records, complete drawing definitions, specs of the products. I'd say key characteristics can be missing in a lot of cases, things like that. Bill of materials, most people are used to seeing bombs nowadays. Any assembly manufacturing tolerances, stack up analysis, lead times, testing requirements, all of these things should form part of the design process, and you should have all these deliverables that you can present in this. Design for maintenance, repair and overhaul, that's often forgotten. A lot of organisations won't think about how we're going to repair this afterwards. They'll put the product out, and then lo and behold, things start coming back, and they haven't actually got a process in place for what they're going to do. Especially if it's maintenance, after 5 years, you need to take this off and wash it, whatever it is. So it's not going to impact all products, but it is quite a common thing out there that, especially if it's flight critical, is the life expectancy of this and what's required for the maintenance process. Special characteristics, let's say, such as key characteristics. Okay. Preliminary risk analysis of sourcing plan. That's quite a good one. Who the suppliers are, what's their qualifications as a supplier, have you gone to visit them? Do you need new suppliers, or can you utilise your current ones? If you've got current ones, you want to then start seeing, can they actually do the levels? Have they got enough resources to be able to fulfil your requirements? It's no good designing something, throwing it out there, and all your suppliers going, we can't make that. So it's asking you to do some front end of that. Just have a look at it, see where the risks are. Speak to your suppliers. Can they actually help you on this? Also, packaging specs. Start thinking about that, how the product in the end needs to be packaged, bubble wrap or polystyrene, whatever method it needs. That's for handling, safe handling, protection. Design reviews, product build plans. So it's how you're going to make up the items, how you're going to assemble them. Design verification, validation, how you're going to test it, how you're going to make sure the product prototype is effective. Start working out the design of experiments that you need to do to validate that what you've designed actually works, things like that. Okay, so process design and development. This is about setting up your process for actually making a bit. So this is where manufacturing organisations kind of get in. So they might not get involved in the phase 1, phase 2. They could come in phase 3 because this is what really impacts them. So if you're not a design organisation, generally phase 1 and phase 2, you don't need to worry about. You'll only kick in at phase 3. It's good to get involved as early on as possible with new product developments. Try and get their understanding on what's expected, what the expectations are. If they've done their part right, the phase 1, phase 2, then really you should get the information quite clearly to be able to sort of manufacture effectively. So process flow diagrams. Maybe the product has to go through certain processes. Maybe you're introducing brand new processes. We've had clients that have set up new assemblies, assembly cells, things like that. So just think about, is the product going through the normal process, or is it going through, you're going to have to create a new cell or anything like that. Floor plan layouts, that's quite important. Again, if you're doing cell management, value stream mapping, lean processes, things like that. Or again, is it just going to go through your normal production? Production preparation plans, qualifying people. Do you have the competence? Do people need to go on specific training courses? You get all kinds of things for electronics. IPC 610, 620, things like that. So maybe this is a new product that requires additional training and resources. Don't leave it to the last minute, because especially at the moment, things are getting quite difficult to get booked on courses, things like that. Process failure mode and effect analysis. Some organisations possibly done these. Something I encourage quite a bit, if you can do. Look at your process, look at the higher risks. It's good for your operational risk management, clause 8.1. Process key characteristics, yeah, identifying the key characteristics. Ask, are there any key characteristics? Very rarely do I ask a client if they've actually asked the customer if there's key characteristics. There's nothing on the drawing. Did you ask them? No. Well, maybe you should start asking those questions, because you could be looking at something manufacturing a certain way and they expected one tolerance to be adhered perfectly and the others don't matter so much. So it will make up, it will make your planning of your production a lot easier if you are aware of any key characteristics. If there aren't, then great, but if there are, you've possibly got to put in some additional controls, additional inspection, possibly additional records. Control plans. I'm going to come on to control plans. I've got another little few slides on that, because I think those are quite important and they're quite valuable for organisations to implement. I've got a little bit on that as separate. Preliminary capability assessments. Have you got the capacity? What's the throughput expected? The volumes? People like Airbus, you know, they put run rates out there. 65 aircraft, there's 12 per aircraft, things like that. And then they give you a plan over 3 years. Now, I know not many organisations will give you a good schedule. You should try and work with them to get a schedule. If they are going through the APQP process, they should have given you a schedule anyway. Again, even if not going through the APQP, it's a good practice to actually ask your customers, do you have a schedule, shipment dates, even if it's approximate, it will help you with your own planning. No good giving you a purchase order for 2,000 if you can't get the material in time, things like that. Customers and suppliers should probably work together a little bit better, really, in communicating what their expectations are, schedules, due dates, things like that. Workstation documentation. You need the process flow charts there, shadow boards. Are they using laptops to record things on? Whatever it may be. Measurement system analysis. Are your people timing okay? The calibration equipment, things like that. Are they up to scratch? Everyone competent? How are they going to measure things, timing wise, throughputs, things like that? There's all kinds of different things that make that up. So if you remember back in earlier on in it, it was asking for a specific document to be produced for that. Supply chain risk management plan. So any risk analysis of your supply chain, what mitigations. I've had a client in the past where their main supplier basically burnt to the ground. Their risk mitigation plan kicked in, got all their other suppliers on board, so they didn't miss a single delivery. And then a year later, once the building was rebuilt, everything switched back over. That's because they actually implemented APQP and they had a risk mitigation plan in place. The customer didn't even really realise there was no delayed deliveries, the quality was still there. It all worked perfectly. Won't always work perfectly, I know, but material handling, packaging, labelling, think about what you need to get in place, any specific boxes, any specific packaging, labelling, things like that. Production readiness review. So that's getting all your documents together. What's the results of all your analysis, what you've learned, any actions you need to get in place. So it's reviewing all your documentation together before you go into the full production. Okay, phase 4. It's about improving the initial products using tools such as your fairs, your PPAPs, things like that. So we've done a little trial beforehand in the previous phase. This is about fine tuning it, making sure the process is robust, signing it off, getting everyone's buy-in. You kind of freeze what it is in that state. So this is how it is, this is fixed, no changing, and we can just run the product into normal production. So, sorry. Okay, so adequate quantity products through your initial trials to complete the fairs or PPAP deliverables. So they might ask you to do a sample run of 5,000 or something like that to approve the product and the process. So have you got all the material needed? Have you got the right material? Can't just use any old aluminium or stainless, things like that. Measurement equipment analysis, so those results, you test them, you then measure them, and then did you meet what you planned to do? Initial CPK levels. So key takeaway here is that CPK is potential of a process to meet a specification, so it's kind of short term, while PPK is what it actually achieved. So a lot of people will mention CPK, but they don't realize PPK is the actual, so that's the difference. Yeah. Control plan, as I say, is completed. So you started your control plan in the previous one. So this one is where you complete it and make sure it's working effectively. Capacity verification, just making sure you can meet the demand. Product validation results of any tests that you needed to do, any sample runs, looking at the tests that you designed in the previous process and just making sure that you've actually achieved those. Is it all signed off? Kind of a commissioning, I suppose, type thing. Yeah. First article inspection, that's something many of you are used to seeing. I think we don't need to go into too much detail on fairs. And then the production part approval process, which is the PPAPs. Okay, so it's an actual file that goes to the customer with your samples, with all of this documentation, all fits together, goes off to them. They'll review it, and then they'll say whether you're ready for full production. Things like that. And then phase 5. So phase 5 more about the ongoing through the life cycle. Any feedback back into the systems and things you need to adjust. So hopefully, if you've done the phase 1 to phase 4 correctly, you shouldn't have too many of these. But when things are really out in the field, getting kicked about, true life examples, so they will come back and you need to do some product design, redesign, redevelopment, things like that. But if you've done phase 1 to phase 4, hopefully this should be minimal. Maybe there's better ways of doing things. Quite often when you set up a machine for the first time, you run the CNC, produces the part, but as the engineers get used to the part, they actually start weeding out some time, so the cycle time comes down. It's all those types of things that can get built in to slowly reduce that time, just to get your lead times down, get the product there to the customers on time. Okay, so just some of the things you do as part of your ongoing monitoring, measuring performance, getting all that data, reviewing the data, things out in the field, things from the operators, what's the inspection results, things like that, and just feeding it all back into the system. Think of it as a loop, keeps going back. Ongoing data analysis, anything out in the field, getting repairs, warranty repairs. Do you analyze the warranty repairs? Are you constantly getting the same issues arising? If you are, you possibly need to do some redesigning or product recall even in some cases. And then keeping a record of the lessons learned. That's always a good thing. Let's say when it gets around to redesigning something or something similar, you can actually use those lessons learned going forward. Okay. I'll kind of whiz through that a little bit just to give you an overview and a little flavour of what the APQPs are about. You'll see there's a lot of detail in them. but some of the elements are quite useful that you can take out. So even if you're not doing the full APQPs or PPAPs, there's some quite useful things you can do in there as an organisation to ensure you get good product on time, keep the customers happy. That's the thing. So I've just done a couple of little slides here on the control plan as well, because I'm starting to see these crop up quite a bit. So although organisations aren't doing the full APQPs, control plans are quite useful. So I'll just sort of cover it very, very slightly here. Again, just a short overview. So benefits of a control plan: they improve the ability to prevent non-conforming products, identifies and manages sources of variation input, reduces variation, reduces scrap and rework, can improve efficiency and cost, with less waste, less cost without sacrificing quality as well. Okay, so quality plans are quite good. I've got some clients that will ask their suppliers to do a quality plan for the products that they're going to manufacture. They'll develop this with the suppliers, and it gives them confidence that they're managing the process okay, and then it reduces their time for inspection when the parts come in. So as long as they're meeting the control plan, it reduces their own risk, and there's less sort of monitoring of their suppliers really. So improves customer satisfaction because the products are getting there on time, much better quality, less returns, so they don't have to inspect things quite as rigorously. Some people might have heard of doctor stock as a process where products come in from the suppliers, they don't even open the box, they go straight either into stock or they go straight to the line, you know, just in line, just in time feeds, things like that. So a lot of them will ask for control plans at least to be produced by the suppliers for those specific parts, which then gives them confidence when the parts are coming in that they should be meeting the requirements. So as long as you're following the control plan, and it will be done per part, it's not an overall risk thing. So improves process management, communicates changes quite well. How many times do customers customers update something and don't inform the suppliers? That happens quite often, especially specs, standards, bit of a bugbear of mine. Yeah, they don't really give you the tools necessary sometimes. They don't flow the information to you. It looks at prevention rather than detection, so error proofing. So it makes you think about things a little bit more. Where are your risks throughout this manufacturing process? And putting in specific error proofing methods, monitoring, things like that. Okay, so interesting bit is the inputs needed for doing a control plan effectively. A lot of these points are things you needed for the APQP anyway, and you need these to be able to do the control plan. So process flow diagrams, FMEAs, PFMEAs, key characteristics, you need all that information as an input to enable you to do a control plan. If you haven't got all these bits, you can't really do it. In all honesty, you won't have all the information you need to fully control that product. And say their key characteristics is an important one that we don't see communicated very effectively, must admit. Okay. So any questions? I'll kind of whiz through that. As I say, we may go and do some more webinars, a bit more detail on the specific phases. But hopefully that gave you a little overview of that. So is there any questions on that or anything in general?
I think you've got a question there, Mike, from Peter Hartland, reference how the phases link up with clause 8.3 design. So how that ties together through the process. Would you be involved? I think you touched on it.
Yeah, touched on it. So a lot of the inputs, I'll click back through. Yeah, so a lot of the inputs here are needed to do the design in the first place, especially things around the project targets. So a lot of these requirements will come into the planning or design clause for 831. Yeah, so it does actually tie in with design anyway. Things it won't, sort of the standard doesn't really force you to do is things like the risk analysis. It alludes to it. It especially need the design records. That's something you need to do, and a BOM you definitely need to do, because that will be part of the outputs of design. You'll have a drawing, but you could also have a BOM. Probably this type of thing isn't in AS9100. The assembly, the tolerances are in there, but stack up analysis, things like that. Key characteristics, that's what I say, that's the weak part. You very rarely see these being communicated effectively. Sometimes you see them tied up in a document somewhere, not visibly available on the drawing. It's not very good practice. Some people will do a KC, which basically means key characteristic. They'll box it, so that focuses the attention of not only the organisation but us. Us as auditors, we can then focus our attention on it, how they're monitoring it, how they're making sure they're meeting that key characteristic. Things like the risk analysis, the sourcing plan, that's not really in AS9100. I think that answers your question. Yeah, so really, Peter, not all the phases. So if you're not a design organisation, you won't do phase 2, basically. Hopefully that answers your question. If not, you got my number. We can chat after. Anything else? Any other questions? No? Give me a couple of minutes. Yeah. Any questions on this or anything else? Auditing, accreditation, anything you like. No, I think that's it. Nothing else come in, has it, Archie? I can see.
No, not at present. That's everything answered at the moment.
Okay, so what we'll do is we'll end it there. Thanks everyone for attending. Hope I didn't send you all to sleep too much. Hopefully you found the content useful and beneficial. The slides will be going out, as we say. Marketing will send them out to anyone who registered, so you will get a copy of everything. If there are any specific questions, feel free to email. You can email aerospace@nqa.com, and so that will go through to the general team, and then they can siphon out the questions to us. Or you can contact me directly, let's say on LinkedIn. I'm always on LinkedIn. Or my email's michael.benner@nqa.com, and Archie's archie.gemmell, G-E-M-E-L-L, at nqa.com. For anything you have at any time, feel free to.
There's another question just dropped in there, Mike, reference PPAP and fares.
Difference between a PPAP and a fare. Okay, so a PPAP, a fare is the single document to approve that process. You take a single product and you measure it, and then you attach some certain documents on. Was there a process, special processes, material certs, things like that. So a fare is part of a PPAP. So the fare is a small element. So the PPAP is a lot more documentation. So it's, for example, a fare, you don't have to do MSA. So the MSA is part of the PPAP. A fare is part of the PPAP. So the PPAP is a bigger thing. It's a collection of a lot more documents, where a fare is just a singular inspecting a specific part. Hopefully that answered your question. You can hang around for a few more minutes if you want. Christine. is a normal process for the customer of a smaller organisation to require certain elements of the PPAP from the supplier. Yes, that's prime example will be a fair. So a lot of people will produce a fair for their customers. They'll take that fair and put it as part of their PPAP, basically. That's what I say. So you can take some of these little elements and apply them to any business without doing the full APQP or PPAP process. But we are seeing PPAP being flowed down a lot more. So instead of just sending a fair, they want you to do a little bit more. Yeah, it's kind of customer driven in a lot of cases, all of this. Because it takes a lot more effort, as you can see. There's a lot of detail to it. You need a lot more resources, a lot more time. And at the end of the day, it's probably going to cost more money to the customer because someone's got to pay for it. Hopefully that answered your question, Christine. So in many cases, the contract manufacturer claims 8.3 not applicable. In those cases, how does, okay. Yeah, so basically those 5 phases, you don't have to implement all 5 phases. So if you don't do design as an organization, you've excluded that. You won't be asked to do phase 2. Yeah, or phase 1. You kind of kicking in 3, 4, and 5. So you can take certain elements out. They'll just ask you to do the 3 or 4 and possibly 5 as well. Yeah. Hopefully that answers it. Through the operational planning. Yeah, so the operational planning part is really the risk assessment, and that's where your control plan can kick in. So the control plan kicked in at phase 3. Yeah, so that will cover you for clause 8.1. So by doing phase 3, 4, and 5, you'll cover AS 9100 clause 8.1. I think that's what I'm reading right on the question. Okay, good. Okay, anything else? Want to go and enjoy the rain? Okay, yeah, I think that's it. Doesn't look to be any more questions coming in. But say if there is, just email our team and we'll get back to you. We've got everyone's email on here anyway. So if something comes in, sometimes a question comes in as we're chatting down, so we can contact you. But contact the team at any time. Okay. Take care, everyone. Thanks for joining.